Hello and welcome to a video on metallic bonding. So we're going to be discussing what metallic bonding is and the properties of metals due to its bonding. So first of all, let's have a quick description of what they are. So they are giant structures of atoms with strong metallic bonds. And these only occur between metals. So before we talked about covalent between two nonmetals, ionic between a metal and a nonmetal, and metallic between two metals. That's quite straightforward. Now, a feature of them is a high boiling and melting point. The only metals that do not follow this is mercury and gallium. Mercury is a liquid at room temperature, and gallium is a liquid when it's in your hands, or at body temperature, which is a little bit warmer, roughly about 35 degrees it will melt. So these are the only two that don't follow this, but you don't need to understand anything why that is. It's just interesting to know. Now, the reason they have a high boiling and melting point of normal metals is due to these strong metallic bonds. As they are quite strong, they're difficult to overcome. It requires a lot of energy to break the metallic bonds. That's what will give it the high melting and boiling point. Right, now we're going to look at how these bonds are formed and what it actually looks like. There's a very good diagram which I'm going to show you now. So let me just clear this and we'll go on. So, they are arranged in layers. And they have what we call a sea of delocalized electrons. Now that sounds quite fancy, but what it literally means is that electrons aren't attached to the atoms. We actually form ions which are positively charged, and that is our cations. Positively charged ions, the electrons have delocalized or detached themselves, so they're not attached anymore, and they are floating around like in the sea. So we have lots of negative charges. I shall do these in red just so we can make them stand out. Lots of negative charges floating about throughout. We do that. Okay, so the sea of delocalized electrons, I'll circle that so we know which it's red. Now, the force of attraction between the positive metal ions and the negative electrons is the metallic bonding. And you haven't just got one, you've got a lot of metallic bonding in there, because you've got a lot of electrons floating about and you've got a lot of positive metal ions. So it makes a very strong bond. That's what leads to its high boiling point and melting point, because you've got a lot of them. Now, as you notice, they are arranged in layers. And that is an important feature of pure metals, and we're going to talk about impure ones in a bit. So the important feature of pure ones is that they are arranged in nice layers, and this means their metals are malleable. And what malleable literally means is can manipulate shape. We can bend it effectively. We can bend metals to however we want. Now, you know that from a paperclip. You get a paperclip, you can bend it around. But that's not a big bit of metal. Admittedly, yes, if you have a huge chunk of iron, it's going to be difficult to bend. But if you start to heat it up and warm it up, it becomes more malleable because we're breaking some of these bonds down. We're making it even more malleable. But the reason that these layers allow for metals to be malleable, the layers can slide over each other. So if they can slide over each other, it means that we can manipulate the shape, making it malleable. Now, one other factor of this, a key feature of it, is the ability to conduct electricity. Metals are amazing at conducting electricity, and also energy in the form of thermal energy. They transfer heat very quickly. And you know that from just holding a bit of metal. It's very cold to start with, but after a couple of seconds, after about 20 seconds, it will be warm in your hand. The energy will have transferred very quickly. And the reason, so this is electrical charge plus thermal energy easily transferred throughout the metal. Now, the reason for this is the sea of delocalized electrons. They carry the electrical charge. So electrons, I'll do E minus for this. I'll do lowercase e. That's proper nomenclature. E minus. So electrons carry electrical charge plus thermal energy. Now, as we said, they're a sea of delocalized electrons. That means they're free to move. They're free to move, therefore they're free to carry the electrical charge or thermal energy. And that's what makes them so good at moving electricity and thermal energy, conducting it. And that's why we use it for wires, and we use it for things like pots and pans, cooking with. If you use plastic, it would melt, whereas metals will stay the same because of the high melting point and boiling point, but also they will transfer the energy very rapidly due to these sea of delocalized electrons. So that is all the properties you need to know about pure metals. But we need to now think about some impure metals and what we call alloys. So I'm just going to clear this all and we'll talk about that. So, alloys. Two or more different metals. So it has the same properties apart from, instead of being malleable, it is not malleable this time. Okay? This time they are extremely strong. And this is because in the original one, the layers were nice and coordinated. But if you're adding another metal in, their sizes don't match up. Now, admittedly, I haven't drawn this perfect with the sizes, but the sizes are roughly equal. But in our example of an alloy, so we'll call this pure metal. Now, an alloy, do over here in green. Let's say you've got a couple of layers, but then all of a sudden, we've got another metal in this place. And that spans over 2 layers. These layers can't slide as easily anymore because the alloy is stopping any movement of the layers. And that's what gives it that strong structure. The layers can't slide anymore, therefore making alloys strong. So when we have strong metals, we have combined 2 metals together to get that. Things like steel. That is an alloy because it is combined together two different metals and makes it very strong. Right, so that is our video on metallic bonding and alloys. Thank you.